Hello! Today we're going to explore a powerful set of tools in arithmetic, divisibility tests. By the end of this video, you will be able to first, understand what divisibility tests are and why they are useful. Second, apply the divisibility tests for 2, 4, and 8 to determine if a number is divisible by them. Third, use a clever shortcut to find decimal answers for division problems that don't divide evenly. And finally, you'll be able to extend these ideas to divisibility tests for higher powers of 2, like 16 and 32. So, what exactly are divisibility tests? They are simple rules that allow us to quickly determine if one number can be divided by another without leaving a remainder. In other words, they help us check for factors. Why are these tests so useful? Well, they can save you a lot of time. Instead of performing long division, you can use a quick test. This is especially helpful for simplifying fractions, finding prime factors, and even for mental math. Think of them as shortcuts that make arithmetic faster and more efficient. Let's dive in and see how they work. Let's start with the simplest divisibility test, the one for the number 2. The rule is very straightforward. A number is divisible by 2 if its last digit is an even number. Remember, even numbers are 0, 2, 4, 6, and 8. So if a number ends in any of these digits, it's divisible by 2. Let's look at an example. Is the number 348 divisible by 2? We look at the last digit, which is 8. Since 8 is an even number, the answer is yes. 348 is divisible by 2. Let's try another one. Is 257 divisible by 2? The last digit is 7. Is 7 an even number? No, it's odd. Therefore, 257 is not divisible by 2. This test works because our number system is based on powers of 10. Any number can be written as a sum of its digits multiplied by powers of 10. For example, 348 is 3 times 100 plus 4 times 10 plus 8. Notice that 110 are both divisible by 2. This means the first two parts of the number are guaranteed to be divisible by 2, so the divisibility of the entire number depends only on the last digit, 8. This simple principle is the foundation for the other tests we'll learn today. We've now seen how to quickly check for divisibility by 2. Now let's move on to the divisibility test for 4. This test is a bit more involved than the one for 2, but it follows a similar logic. The rule is, a number is divisible by 4 if the number formed by its last two digits is divisible by 4. So you don't need to look at the entire number, you just need to focus on the tens and ones place. Let's try an example. Is the number 324 divisible by 4? We look at the last two digits, which form the number 24. Now we ask, is 24 divisible by 4? Yes, 24 divided by 4 is 6. Since 24 is divisible by 4, the entire number 324 is also divisible by 4. Let's try another one. Is 17057 divisible by 4? We look at the last two digits, which form the number 57. Is 57 divisible by 4? Let's see. 4 times 10 is 40. 4 times 14 is 56. And 4 times 15 is 60. 57 is not a multiple of 4. Since 57 is not divisible by 4, the entire number 17057 is not divisible by 4. The reason this test works is similar to the test for 2. Any number can be written as a sum, where the first part is a multiple of 100, and the second part is the number formed by the last two digits. For example, 5324 is 5300 plus 24. Since 100 is divisible by 4, any multiple of 100, like 5300, is also divisible by 4. This means the divisibility of the whole number depends only on the last two digits. 24. So to check for divisibility by 4, Just focus on the last two digits. We've now covered the test for 4. Let's continue this pattern and look at the divisibility test for 8. Following the logic from 2 and 4, the rule for 8 is a number is divisible by 8 if the number formed by its last 3 digits is divisible by 8. This means you only need to check the hundreds, tens, and ones place. The rest of the number doesn't matter for this test. Let's work through an example. Is the number 12,344 divisible by 8? We look at the last 3 digits, which form the number 344. Now we need to check if 344 is divisible by 8. We can do this with a quick division. 344 divided by 8 is 43. Since 344 is divisible by 8, the entire number 12, 344, is also divisible by 8. Let's try another one. Is 7,123 divisible by 8? We look at the last 3 digits, which form the number 123. Is 123 divisible by 8? Let's see. 8 times 10 is 80. 8 times 15 is 120. And 8 times 16 is 128. 123 is not a multiple of 8. Therefore, 7,123 is not divisible by 8. The logic behind this test is the same as before. Any number can be written as a sum where the first part is a multiple of 1,000 and the second part is the number formed by the last 3 digits. For example, 12,344 is 12,000 plus 344. Since 1,000 is divisible by 8, any multiple of 1,000 like 12,000 is also divisible by 8. This means the divisibility of the whole number depends only on the last 3 digits, 344. So to check for divisibility by 8, you only need to check the last 3 digits. We've now covered the test for 8. So far, we've focused on numbers that are perfectly divisible. But what if they're not? Let's explore a shortcut to get to a decimal answer. This method is especially useful when dividing by 4 or 8, as it connects directly to our divisibility tests. The shortcut is to find the largest multiple of the divisor that is less than the number you're dividing. Then, you divide that multiple and handle the remainder separately. Let's see this in action with an example. Let's calculate 57 divided by 4. First, we find the largest multiple of 4 that is less than 57. We know that 4 times 14 is 56, so we can rewrite 57 as 56 plus 1. Now, we can split the division. 57 divided by 4 is the same as 56 divided by 4 plus 1 divided by 4. We know 56 divided by 4 is 14, and 1 divided by 4 is 0.25. Adding them together, we get 14.25. This is a much faster way to get the decimal answer than long division. Let's try another one, this time dividing by 8. Let's calculate 125 divided by 8. First, we find the largest multiple of 8 less than 125. We know that 8 times 15 is 120. So we can rewrite 125 as 120 plus 5. Now we split the division. 125 divided by 8 is the same as 120 divided by 8, plus 5 divided by 8. We know 120 divided by 8 is 15, and 5 divided by 8 is 0.625. Adding them together, we get 15.625. This shortcut is a great way to build your mental math skills. We've now learned a powerful shortcut for division that doesn't result in a whole number. We've seen the pattern for 2, 4, and 8. Can we extend this to higher powers of 2? Absolutely. Let's recap the pattern. For 2, which is 2 to the power of 1, we check the last 1 digit. For 4, which is 2 to the power of 2, we check the last 2 digits. For 8, which is 2 to the power of 3, we check the last 3 digits. Do you see the connection? The exponent of 2 tells you how many digits to check from the end of the number. So for 16, which is 2 to the power of 4, the rule is a number is divisible by 16 if the number formed by its last 4 digits is divisible by 16. Let's try an example. Is 123, 456 divisible by 16? We look at the last 4 digits, which form the number 3, 456. Now we need to check if 3, 456 is divisible by 16. We can do this with division. 3, 456 divided by 16 is 216. Since it divides evenly, 123, 456 is divisible by 16. And for 32, which is 2 to the power of 5, the rule is a number is divisible by 32 if the number formed by its last 5 digits is divisible by 32. As you can see, the numbers get larger, so the test becomes a bit more work, but the principle remains the same. This pattern holds true for any power of 2. We've now extended our understanding of divisibility tests to higher powers of 2. Let's quickly recap what we've learned today. We started by understanding that divisibility tests are shortcuts to check if one number divides another without a remainder. They are incredibly useful for simplifying calculations. We then learned the specific tests for powers of 2. For 2, we check the last digit. For 4, we check the last 2 digits. For 8, we check the last 3 digits. And this pattern continues for 16, 32, and so on. Finally, we discovered a clever shortcut for division problems that don't divide evenly. By splitting the number into a multiple of the divisor and a remainder, we can easily find the decimal answer. These tests and shortcuts are powerful tools that can make you a more confident and efficient mathematician. Practice them, and you'll see how much time they can save you. Now, for your homework, I'd like you to try this problem. First, determine if the number 25,728 is divisible by 2, 4, 8, and 16. Second, use the shortcut we learned to calculate 315 divided by 8. Take your time, apply the rules, and see what you get. Thank you for watching.